All right, welcome back, guys. This is TSI Math Crash Course Day 2, Part 2. There was a little issue with the recording on the Part 2 session. Back to the issue is I forgot to press the record button, so I'm kind of redoing this on my own. We don't have a whole lot of questions in Part 2. Part 1 was a little bit longer, but we've got a couple questions still to go through to finish the Day 2 section. So I'm going to start with question number 3, and I'm going to guide you through this. We'll start with the question. What is the number of grams in 500 kilograms? And they tell us here that 1 kilogram equals 1,000 grams. So again, let's look at the rules for TSI Math real quick. I want to use basic logic and estimation whenever possible, and use the process of elimination to test answer choices also whenever possible. That's rules number 1 and 2. So let's do this here without doing any calculation or any operation. Let's just think about this one logically, okay? All right, so we know that there are 1,000 grams in 1 kilogram. So, and the question is asking us, what's the number of grams? So are we talking about a lot of grams or just a small number of grams? Well, if 1 kilogram is 1,000 grams, 500 kilograms is a lot more grams. We're talking about a very large number here. Okay, so right off the bat, I know I can eliminate answer choice A. I'm not talking about a small number of grams. We're talking about a huge number of grams. Again, if 1 kilogram is 1,000 grams, then 500 kilograms is a lot more grams. Does that make sense? I hope so. All right, so let's look at answer choice B. I just want to think about this logically again. Could the answer be 5,000 grams? I don't know. I'm just using kind of basic logic and basic estimation here. If 1 kilogram is 1,000 grams, which we know it is, because they tell us, then I think I can easily figure out what 5,000 grams would be. 5,000 grams would be 5 kilograms, not 500. So I can eliminate answer choice B. That number is just way too small. Well, what about answer choice C? 50,000. Well, that's 10 times answer choice B, right? It's 10 times answer choice. We're just adding one more zero on the end of that. So my suspicion is instead of 5 grams, or 5 kilograms, which would be answer choice B, I'm guessing like 50 kilograms would be answer choice C. Because 50 times 1,000 would be 50,000. Now I'm sort of seeing where the operation is here. And I know, again, answer choice C already, I think is way too small. It's looking at like answer choice D. Okay. And if you're just going to guess at this point, I think you could pretty comfortably guess answer choice D, and it's correct. Let's use the conversion units operation. We haven't done that yet. So I'm going to go to the rules for mathing here. We're going from one unit to another. Let's see what we got here. Conversion units. Ah, yes. Okay. So conversion units. And I've got an example here of the use of conversion units. If I want to turn 1.5 hours, 1.5 hours into minutes, I multiply by 60 minutes over 1 hour. The hours cancel out. Notice right here, this hours right here, this 1.5 hours is essentially in the numerator. Okay, because 1.5 hours is the same as 1.5 hours over 1. So that 1.5 hours is in the numerator. The hours cancel out because I've got some unit, just like you can do this with numbers. If you've got the same unit in the numerator as you've got in the denominator, or the same value in the numerator as you've got in the denominator, you can cancel it out. We can do the same thing with units. I've got hours in the numerator right here, and I've got hours in the denominator right here. Those are going to cancel out, leaving me with only minutes, right? This is why conversion units work. I'm going to show you how it looks on the whiteboard here in just a moment. And this is kind of the trick when you're doing conversion units, okay? You're going to put the unit you want to go into in the numerator, okay? And if we're converting 1.5 hours into minutes, again, we put minutes then in the numerator. That's the top of the fraction. And the unit you want to go away from, you're going to go away from hours in the denominator, which is why they're going to cancel out. Denominator, numerator, cancel out. You're left with just minutes, okay? Let's go back to the question. Question number 3. Now, we're not going between minutes and hours or hours and minutes. We're going between kilograms and grams. Okay, so let me show you how this looks when we set up using conversion units. So I've got 500 kilograms, 500 kg. Okay, and we're going to multiply this by a conversion unit to get into grams. Okay, so multiply. That's conversion. I like setting them like this. I set up the fraction. And before I start putting any values in, I think about the units we're going into, right? We're going into grams. So I'm going to put grams in the numerator. Remember that it says in the rules, the unit you want to go into, put in the numerator, the unit you're going away from, put in the denominator. And we're going away from kilograms or kg. Okay. At this point, you got to ask yourself, how many grams are there in a kilogram, or how many kilograms are there in a gram? And honestly, it doesn't matter either way. As long as we have the amount of grams equaling the amount of kilograms, we're going to be okay. Okay? And I know, because they tell me here, right here in the problem, once again, that 1 kilogram equals 1,000 grams. I can place those values in to the conversion unit. So 1 kilogram is the same as 1,000 grams. So I'm putting 1,000 here in the numerator for grams, and then 1 in the denominator for kilograms. Okay. The reason why this works, if you think about it sort of logically here, 1,000 grams right here is the same. That is, it equals 1 kilogram. The exact same. Okay, the exact same value. Okay, I know the numbers look different, but 1,000 grams of something is the exact same as 1 kilogram of something. Okay, so we've got the same thing basically being divided by itself. And what's anything divided by itself? Well, anything divided by itself is just 1, right? 7 divided by 7 is 1. 10 divided by 10 is 1. A billion divided by a billion is 1. Anything divided by itself is 1. So in a sense, you could say that this whole conversion unit is really just 1, which it is. Right? We've got something being divided by itself. So we're not going to change the value of 500 kilograms. We're just going to change the form of 500 kilograms. We're going to change it into grams. Okay? So let's start canceling some things out. Notice I've got kilograms in the numerator right here, and kilograms in the denominator right here. I can cancel this out. Gone. Cancel that. Again, the same thing with numbers. If you had a 10 in the numerator and 10 in the denominator, you could cancel it out. 10 divided by 10 is just 1. So it sort of disappears. So the kilograms essentially disappear. I'm left with just grams. And then we see the operation is really just 500, which is in the numerator, times 1,000. And what's 500 times 1,000? I'm guessing they'd let you use the calculator here on this section of the TSI. But you can also kind of figure it out logically. We've got 500 1,000 times. That's 500,000, which it is. And so that's going to leave us with 500,000, 2, 3, grams, which notice is indeed answer choice D. All right, let's do the next one. I'll clear the whiteboard. I think we've got a little bit more here with conversion units coming up. All right. Aha. All right, we'll give that here a minute to load. My whiteboard seems like to be a little crazy. There we go. Okay. All right, so question number 17 reads, the elevation at the summit of Mount Whitney is 4,418 meters above sea level. Climbers begin at a trailhead that has an elevation of 2,550 meters above sea level. Okay. What is the change in elevation to the nearest foot? Notice when they underline something, by the way, make a special note of that. I would circle that. I know it's underlined, but you got to really make a special note. They don't want that change in elevation in meters. I think that's pretty straightforward. They want change in elevation in feet, so we're going to have to use conversion units here. Change in elevation nearest foot between the trailhead and the summit. Before we do anything here, before we do any calculations, you can start really thinking this one through much. I want to draw a picture. And I think this is really essential for word problems. If you can draw a picture, you always want to draw a picture. Okay, so let's draw a picture. We've got a mountain. Okay, and this picture's going to be rough. It's not art class here, this is TSI Math. We've got a mountain. All right, got a mountain. We know the elevation of this mountain, Mount Whitney. It is 4,418 meters above sea level. So this elevation right here, the top point, whoop, right here, is 4,418 meters. Okay. Then it tells us the climbers begin at a trailhead that has an elevation 2,550 meters above sea level. So that's up still. It's not up, maybe like halfway, just a little bit more than halfway. It's something like this. Here's the trailhead. All right. And that's 2,550 meters right there at that point. Okay. And that trailhead leads up to the summit. So like, woo, got a little trail, woo, going up to the top. Okay. All right, and so far, again, I'm not doing any calculation or anything fancy like that. I'm just kind of laying out the problem and drawing a visual representation of the word problem. I can't recommend this enough if you're able to, or if we're talking about like a sort of a physical scenario, always draw out a picture. It's going to help your understanding of the problem a lot. Okay, they want to know the change in elevation of the nearest foot between the trailhead and the summit. I don't know that yet, but I think we can pretty easily figure out what the change in elevation is in meters. Okay, what's the change in elevation from 2,550 meters right here to 4,418 meters? And I think just sort of logically we can figure it out. I've just got to subtract 2,550 from 4,418, which I'm going to do. Got 4,000. Punch this into the old iPhone calculator. 418 minus 2,550. It's going to give me 1,868. Now I want to stop and kind of just consider this logically. Kind of feel this one out. 1,868 meters. Does it make sense that if I'm starting at an elevation of 2,550 meters and I go up another 1,868 meters, would that give me something close to 4,418 meters? I think just kind of logically we can feel that out. And the reason I like stopping and just considering, the numbers that you're coming up with, just so you make sure you're in the right track. Like if I was like, well, what's the operation? I'll add them, and if you add them and you thought about it logically, if I'd get like 6,000 meters as a difference between them, that doesn't make much sense, right? If I'm going up 6,000 more meters, I'm not going to end up with 4,418 meters at the top. So just kind of feel it out and use your basic logic, use your basic estimation skills to sort of check your work as you go along. Okay, don't just kind of settle on an operation and just kind of hope that you got it right. We can sort of confirm this using basic logic. Okay, so I feel pretty confident saying it's 1,868 meters. So I can add those again just to double check, but I feel pretty confident that that's the right value there. Okay, so I know that. Now notice the question isn't asking us what the change in elevation is in meters. We've already got that figured out. The question is, what's the change in elevation in feet? Okay, so a couple ways to approach this. We can approach this by doing conversion unit. I'm going to want to do that. We're going to do that. But first, let's kind of look at this sort of logically here. Okay. Notice it tells us here that 1 foot is 0.3048 meters. Okay, so I want to think about this. What's bigger, a foot or a meter? What's bigger, a foot or a meter? And if you've ever worked with a meter stick, again, let's make this concrete. You know what I'm talking about. Like a meter's pretty big. In fact, from my chemistry and physics class especially, I suppose, I recall a meter stick being almost like a yardstick, right? So a meter is around 3 feet. So we're going to have something close to 3 times 1,868. I'm just kind of feeling that out logically again. Okay. It's going to be something close to that. And just knowing that, I can eliminate 2 answer choices that just aren't close to 3 times 1,868. I can eliminate answer choice A. I can eliminate answer choice D. Answer choice A is just way too small. I know, if we're trying to go in feet, it's not going to be a smaller number of feet. Feet are smaller. It's going to be a bigger number of feet than 1,868. Then I'm looking at answer choice D and that's way too big. That's almost 10 feet in a meter, and I know it's not that big. That would have been a huge ruler. And I know it was something like a yardstick. Again, it was just around 3 feet. I think a little bit bigger than 3 feet. Okay, so just feeling that one out, it's either answer choice B or C. If that's as far as you get on a tough problem, if you're not really comfortable with conversion units, I'm okay with that. You've got a really good shot, 50-50 chance. You're basically flipping a coin, whether it's going to be B or C, and that's okay. I'm cool with that. Okay, but let's see if we can be more precise here. I think we're going to have to find the exact right answer. We're going to have to do the conversion unit. Okay, let me zoom out here, and we're going to do the operation with the conversion unit. Okay, so we're going from 1,868 meters, okay, and we're going to go into feet. Okay, so I'm going to multiply it by the conversion unit. Again, start with a fraction, and remember the unit we want to go into, we're going to put in the numerator. Okay, and we want to go into feet, so I'm going to put feet in the numerator. The unit we want to go away from, meters, we're going to put in the denominator. Okay, and that makes sense again because meters, we got meters in the numerator right here, meters in the denominator, they're going to cancel out. Okay, now the question once again is how many feet are there in a meter, or how many meters are there in a feet? It doesn't matter what we pick as long as it's the same value. Okay, now remember the question says here 1 foot equals 0.3048 meters. All right, so that's all I got to do here. I just got to put 1 foot right here and then put 0.3. Ooh, that's an ugly 3. I'm going to fix that. 0.3048 meters. Okay? All right, right off the bat, I know that meters is going to cancel out, which they do. I'm just left with feet, which is going to be good. And then the operation here has got to multiply. Remember that 1,868 meters is in the numerator, essentially, and there's like a 1 in the denominator, right? And you divide by 1 itself. So when we were multiplying fractions, in case you forgot, we just multiply across the numerator. So 1,868 times 1 foot is 1,868 feet divided by 0.3048. Remember, the meters is already canceled out. So all I got to do is just do the calculation. And again, this would be a part of the TSI where you definitely have a calculator handy, probably popping up on the screen. And so let's carry out that calculation. Punch it into my iPhone right now. So I've got 1,868 divided by 0.3048. And that gives me 6,128.6, and again, feet, so we're left in feet. And I'm looking at the answer choices. Which change in elevation is nearest to that in feet? Oh, answer choice C, clearly. All right, if we round up, we would get that. It's definitely not answer choice B. That's not even close. Okay. All right, so a couple things here. Takeaways for this problem: if you can draw a picture, always draw a picture. Second takeaway I would say is stop, in the middle of the problem, stop and sort of just use sort of basic logic and your estimation skills to make sure that you're on the right track, that you just haven't carried out an operation, you haven't just like slapped two numbers together and hoping you got the right operation. We could confirm, for example, that the difference between the elevation was 1,868. We can confirm that with basic logic. And then the last takeaway is use those conversion units. Remember, the unit you want to go into, put in the numerator, unit you want to go away from, put in the denominator. And you can confirm that with the conversion unit. All right, that was question number 17. Just a couple more here for part 2. And these are some of the basic concepts. Yes, mean. Some basic concepts, and again, these are all on the rules for mathing here. But let's read the question first. We'll talk about how to approach the question. Okay. Question number 7 reads, the table above gives the population of the 5 largest countries in the European Union in the year 2014. Which of the following is closest to the mean population of these countries? Okay, so first we've got to really know some of the terminology here in this question. We've got to know what mean means. Before we do that, let's underline the last sentence of the question. I really like that strategy on a word problem. It'll help us focus. Which of the following is closest to the mean population of these countries? Okay, so mean population, that word right there, we got to figure out what that means. I've got that on the rules for mathing. I've got, it's a type of average. Mean is a type of average. And I know you've heard that. There's some different types of averages here. I want to go over this real quick. There's a good chance you could see any of these on the TSI. Okay, the most common one, of course, is mean, which is classic average. Okay, mean means classic average. To find the classic average, you add up all the values and then divide by the number of values. Okay, that's classic average. Let me give you an example of that. Imagine you're playing soccer. You're playing three soccer games. In one game, you score 1 point. In a second game, you score 2 points, 2 goals. And in the last game, you score 3 points. Okay, 3 goals. So to find the average, or the mean, the classic average, you add up all the goals. So that's 1 plus 2, which is 3, and then 3 plus 3, which is 6. So 6 goals you scored in those 3 games. And you divide by the number of values. We had 3 values, right? So 6 goals in 3 games. 6 divided by 3 is 2. Your mean score is 2. Okay, that's how you find the mean. All right, so we've got to add up all the values divided by the number of values. We're going to get to that in the question. Real quick, I want to go over median. Okay, median is the middle number when you line up a series of values from smallest to greatest. If they're in random order, if they're not smallest to greatest, you don't just pick the one in the middle. That's not going to work. You've got to line them up and order them from least to greatest to least and pick the middle number. If it's an odd number of numbers, the middle number is pretty easy to find. If it's an even number of numbers, and not really a middle number, there's really 2 middle numbers, then you have to find the mean of the 2 middle numbers. Okay. Mode is another interesting type of average. Mode is the most frequently occurring number. So let's say another set of games, I scored 1 goal in one game, 1 goal in the second game, and then the last game I scored 7 goals. Okay. Well, the most frequently occurring number is 1, right? So that would be the mode in that set of 3 games. And it'd be very different if I were calculating mean. Okay. So anyway, and then range is the difference between the highest number and the lowest number in a set of values, right? So just take the highest and subtract the lowest, and the difference between those is the range. Okay. Here again, all we need is mean. That's classic average. Add up all the values and divide by the number of values. Okay. So let's go back to the question. What is the font is closest to the mean population of these countries? Okay. Okay. I think before I even calculate the mean, and I think you're sort of seeing the directions it's going to go on. I've got these different values here. If I add all those values up and divide by the number of values, 5, I should be able to find the mean. We're going to do that. But now knowing the other types of averages, right, median and mode, I'll bet we can eliminate some of these obviously incorrect answer choices. Okay. Look at answer choice A. That's the highest value, right? 80.8 million. There's no way I'm going to add up 5 numbers, all of them lower than 80.8 million. There's no way I'm going to do that and get 80.8 million. They just pick the highest number. Right? That's clearly not the average. Certainly not the mean. Okay, so I can easily just logically eliminate answer choice A. Okay. Another answer choice that I feel pretty comfortable eliminating is answer choice D, 60.8 million. The reason for that is that's the middle number right here not in the middle, like arrange them from smallest to greatest. I think it's actually like the second smallest. But like they just kind of picked the middle one in the chart, the physical middle, right? And they're trying to throw you off with that. Some students know how to pick, the median, and they're just going to look at it and be like, oh, it's the middle one. Yeah. No. They're trying to throw you off there. That's definitely not classic average. And the likelihood that I'm going to add up all of those values and get a value on the chart, I mean, it's possible, but the likelihood I think is pretty small. And it's certainly not going to be the second biggest number. It might be the one in the middle, but it's not going to be answer choice D. So again, if I were just guessing right now, it's either B or C. Okay, and that just makes sense, right? If I'm looking at the values, I'm just kind of feeling it out with some basic estimation. It's going to be something like in the 60s. That feels about right. Mid-60s, right? Not like 80 is way too big again. 60, that 60.8 just feels too small. Something in the mid-60s feels about right. Okay, and it is either answer choice B or C. Okay, let's carry out the operation now. Now we know we've got to add up all these 5 values here, and this is definitely going to require some calculator action. No problem. Let's do it. So I've got 65.9. I'm going to add 80.8. Then I'm going to add 60.8. Then I'm going to add 46.5. Then I'm going to add 64.3. That gives me 318.3. Don't just round that, by the way. If they give you a precise number, you want to be as precise as possible here. When we're doing calculating, especially with decimals, right? You might round at the very end, when you're looking for the correct answer choice. But in the middle of the calculation, try to keep your decimals as precise as possible. So, all right, so 318.8, not just 318. All right, so that is the total population of all those 5 countries. Now remember to find the mean, classic average. I take the values I've added up and then divide by the number of values. And how many values do we have here? Well, we've got 5 values. Right? France, Germany, Italy, Spain, United Kingdom. It's 5 countries. So I'm going to divide by 5. Again, just easily go calculator here. Divide by 5. And iPhone says 63.66. Okay. All right, so that is my mean number of population of these countries. The question is which of the following is closest to the mean population? Both the answer choice B and C are pretty close, but the closest, and again, that's why you want to be really precise with your decimals here, the closest by far is answer choice C, which is the correct answer. Okay, 63.7 million, which is essentially 63.66 million rounded up. I'm also looking at answer choice B now, and I see where they got that from. If I were to line up all these 5 values from smallest to greatest, the middle number, the median number, again, not the physical middle, but the median would be 64.3. So that's where they're trying to throw me off there. You really have to know your definitions. Not a ton that you have to memorize. Again, I mean, the basic concept cheat sheet is relatively small. I'll be adding to it as we move along the course, but thus far you don't have a ton to memorize. But you really do need to know mean, median, and mode. And the most likely one that you're going to see tested on is probably mean, but be aware of the others as well. Okay. All right, and that is averages, specifically mean. Clear that? I think I just have one more question coming up. Yes, probability. They are going to test you on probability. Okay. Question number 14 reads, the table above shows a survey of 50 registered voters in a city. Each voter was asked whether they plan to vote yes or no on 2 different issues. The voter who plans to vote yes on issue P is randomly selected. What is the probability that the voter also plans to vote yes on issue Q? I'm going to underline the last sentence of this question here. So the first sentence here is just kind of setting this up. If a voter plans to vote yes on issue P is randomly selected, what is the probability the voter also plans to vote yes on issue Q? Okay, you've got to know what probability is here. Okay, just something you have to know. If you don't know, good luck on this one. You're not going to get it. There's no amount of like basic logic or estimation that's going to help you get this one. Here you've got to know kind of what probability is and how it works. Okay, and I've got this lucky for you on my rules for math, TSI Math. Probability here, this is the definition of probability, sort of formula for probability. Probability equals winners or the winning outcome you're looking for. Okay, I've shown that to winners. Winners are the winning outcome divided by the total number of possible outcomes. Total number of possible outcomes. I'm going to express that kind of a different way on the whiteboard to make it really, really clear. Okay, probability equals winners, or the winning outcome you're looking for, same thing, divided by the total number of possible outcomes. Okay, and let me give you some concrete examples here of what that looks like. Okay, I love talking about 6-sided die when it comes to probability. Okay, you roll the 6-sided die, you know what I'm talking about. Like we're talking like dice for Monopoly, right? It's got 6 sides and it's got the numbers 1 through 6, right? And just there's just one number on each side. If I asked you, what's the probability of rolling a 2 on a 6-sided die? What's that probability? Okay, well, let's just look at the probability formula. Okay, and I love starting with the denominator on a probability problem, right? Start with the total number of possible outcomes. Okay, so on a 6-sided die, what's the total number of possible outcomes? I mean, how many different numbers are popping up potentially? Right? There's 6 sides, so the total number of possible outcomes is just 6. Right? It's pretty straightforward. On a 6-sided die, there's 6 possible outcomes. Right? You're either going to roll a 1 or 2 or 3 or 4 or 5 or 6. That's 6 different possible outcomes. Right? Compare that to like a deck of 52 cards. I'm talking about the probability of picking a particular card or a particular set of cards out of a 52 card deck. The total number of possible outcomes is going to be out of 52. Right? No matter how many winning outcomes are there, there's 52 cards. That's the number of possible outcomes. And a 6-sided die, there's 6 sides, so 6 possible outcomes. Okay. All right. So the total number of possible outcomes is 6 on a 6-sided die. And I said, what's the probability of rolling a 2 on a 6-sided die? Okay. Well, how many winning outcomes is that? Well, a winning outcome would be rolling a 2, and there's only 1, 2 on a 6-sided die. So the probability would be 1 over 6. Okay. We could also express that as a decimal. Okay, I could literally divide 1 by 6, which I'm going to do in my calculator real quick. 1 divided by 6 equals 1.16666666 for infinity, 7 ultimately around it. Okay, and this is the deal with probability. Probability is always going to be a fraction less than 1, or 1 or less than 1, between 0 and 1, or a decimal between 0 and 1. Could be 0, could be 1. Okay, but it's not going to be bigger than 1. Okay, just be aware of that with probability. Okay, the reason for that is that like a probability of 1 is like that is going to happen. There's no way around it. It's just going to happen. Like what's the probability of rolling a 1, 2, 3, 4, 5, or 6 on a 6-sided die? Well, that's the total possible outcomes is still 6, and the winning outcomes, there's 6 winning outcomes, right? Because I said, what's the probability of rolling either a 1, a 2, a 3, 4, 5, or 6? There's 6 winning outcomes. 6 divided by 6 is 1, right? There's a 100% chance when you roll a 6-sided die, you're going to get either a 1, a 2, a 3, a 4, a 5, or 6, right? I can't get like bigger than 100% chance of something happening, right? Like that's absolute certainty, which doesn't happen a whole lot in life, but sometimes. Right, death and taxes, right? You're going to die, you're going to pay taxes. Okay, great, that's 100% chance. Okay, fine. Well, other than that, there's no guarantees, few guarantees. But so that's 100%, or 1 over 100 is 1. A 0% chance of something happening is 0. So if I said, like, what's the probability of rolling a 7 on a 6-sided die? Well, there's no 7 on there. So the winning outcomes, there's 0 7s. So that would be 0, 0 winning outcomes out of 6. Anything, 0 divided by anything is 0. So the probability would be 0 then. Okay. Let's go back to the 6-sided die example. What if I said, what's the probability of rolling a 2 or a 3 on a 6-sided die? Okay, the probability of rolling a 2 or a 3. Well, the total possible number of outcomes on a 6-sided die is still 6, so that still stays the same. I don't change that. But now, how many 2s or 3s are there on a 6-sided die? There's 1, 2, and there's 1, 3. So I've got 2 possible winning outcomes out of 6. So that would be a probability of 1/3 or 0.33333333, the same thing. That's a very ugly 3. Okay, a little bit better. What if I said, what's the probability of rolling a 2, a 3, or a 4 on a 6-sided die? Well, suddenly I've got 3 winning outcomes, right? Because there's a 2, the 3, and a 4. That's 3 winning outcomes out of 6. Suddenly my probability is 1/2 or 0.5, right? Same thing, you can express it either as a fraction or as a decimal. 1 divided by 2 is just 0.5. Okay. All right, so again, with probability, I always start with the total number of possible outcomes, because that's the pool that you're drawing from, right? I know the winning outcomes aren't going to be bigger than that. So start with the total number of possible outcomes, and then decide what your winning outcomes are from that set. Okay, so let's do that. Let's take that approach here on this question, using that formula for probability. Okay. All right. So the question is, if a voter who plans to vote yes on issue P is randomly selected. Okay, that's our total number of possible outcomes. We're talking about randomly selecting a voter who plans to vote yes on issue P. Okay, so the question naturally is, well, how many voters plan to vote yes on issue P? Okay, and I'm looking at this chart. I'm trying to figure this thing out. Now, this column right here, though I'm on the erase function, not the draw function. This column right here, this is voters that plan to vote yes on Q, and voters who plan to vote no on Q. But we're not interested in Q, not just yet. We're interested in those that plan to vote for P. And I'm looking here, in that section. That's voters who plan to vote yes on issue P, and this one's voters who plan to vote no on issue P. Well, we want to know if a voter who plans to vote yes on issue P is randomly selected. So I want that top row right there. Okay, the voters that plan to vote yes on issue P. Okay. All right. So so if one of those guys is randomly selected, well, how many guys, voters, right? Guys or girls? How many voters plan to vote yes on issue P? Okay, just kind of study the chart here. I think we can pretty easily determine what we're talking about. 20 possible voters, right? That's the total number of voters who plan to vote yes on issue P. Okay. 20. Might be like, well, what about 8 and 12? Well, those are the guys that plan to vote yes on P and yes on Q. There's 8 of those guys, and then 12 guys plan to vote yes on P and no on Q. Okay, but the total guys that plan to vote for vote yes on issue P is 20. Okay, and that tells us they're in that total column on the right-hand side. Okay, so I feel pretty comfortable putting a 20 in the denominator, and you can. Yeah. So if a voter plans to vote yes on issue P is randomly selected, okay, so of those 20 guys, those 20 voters, what is the probability that that voter, or that the voter also plans to vote yes on issue Q? So of the 20 voters who are voting yes on issue P, what's the probability that voter also plans to vote yes on issue Q? So, well, of those 20, how many plan to vote yes on issue Q? Well, we got 8 are voting yes and 12 are voting no, right? But 8 is our winning outcome. That's the outcome we're looking for. Okay, there's 8 possible guys out of the 20 that are voting yes on Q and voting yes on P. So I'm going to put 8 in the numerator. Okay. If they said if a voter plans to vote yes on issue P is randomly selected, what's the probability that voter also plans to vote no on issue Q? I'd pick 12. That's 12 out of 20 if it was no on issue Q. But it's asking us which one plans to vote yes on issue Q. Clearly, that's 8 out of those 20 total voters also voting for yes on issue P. So the probability is 8 out of 20. But notice I don't see 8 out of 20. I don't see any fractions in the answer choices. I only see decimals, right? So we've got to convert that 8 out of 20 into a decimal. So the old calculator comes in handy. So I'm going to divide 8 divided by 20. And I get 0.4. 0.4 is the exact same as 0.40, which is answer choice C. Woo! That's probability. Woo! You just got to know what probability is there. Okay, know that formula. Winners, or winning outcomes, divided by the total possible number of outcomes. You just got to know that. But again, before you take this test, I really strongly recommend that you study the basic concept cheat sheet, the rules for TSI Math, so that you're going in fresh, having that understanding in your memory, and you're able to apply it. So, all right, I think that ends it for part 2. In the day 3 session, we're going to be jumping into algebra a little bit, specifically how to avoid algebra happily, even on algebra questions. So the level of difficulty bumping up a little bit, but we're gonna be able to cover everything. If you know this stuff that we're covering here in this class, you're just gonna rock the TSI. So, thanks for your attention, and if you got any questions, feel free to reach out to me anytime, and I look forward to seeing you guys soon. Thank you.